Hey, welcome back today. Today, what our focus is going to be is monomials. So yesterday we learned about exponents and base. Today we're going to dive even deeper about monomials. I have vocab already written down here, so I'm going to add the 5 vocabulary words that we're going to come across today. Monomial is the first one that you should hear, monomials. You're going to hear something about the law of exponents. You're going to hear the word product, which some of you already may know. You're going to hear the word quotient, which is another word that you may have heard previously. And then another word is coefficient. So let's go ahead and dive into our first example here. We're going to talk about product of powers. Product of powers basically means multiplying of powers. So it's when you multiply powers by one another. So for example, when you take 2 to the 4th and you multiply it by 2 to the 3rd. All right. There's a thing called law of exponents. A law is basically something that's written, all right, that you have to follow. All right, the law of exponents basically say this. When I'm multiplying products of the same base, I simply take the 2 exponents and I add them together. So what I'm going to do is since these both are being multiplied by 2, I'm going to keep the 2. And I'm going to take the 2 exponents of 4 and 3, and I'm going to add those together. So I'm going to do 2 to the 4th plus 3. When I add 4 to the plus 3, I get an answer of 7. So my simplified version will be 2 to the 7th power. All right. Let me show you with an algebra 1. An algebra 1 would be like a to the m times a to the n. In this case, again, notice that both the bases are a's, so I can use the law of exponents. All right, so I'm going to put my base of a down there. I'm going to take my exponents of m and n, and I'm going to add those together. I do not know the values of m and n, so therefore, this is my final answer in algebra. Whereas in product of powers, I got an answer of 2 to the 7th, which I could simplify and evaluate. All right. So let's see this done with some examples. So the first one I have here is 5 to the 2nd times 5. I notice immediately, this looks a little different. This 5 does not have an exponent in it. All right. It doesn't mean that it has a 0 up here. We actually write that another way. So I'm going to rewrite the 5 to the 2nd because that's not going to change at all the way it looks. The 5, I'm going to rewrite with an exponent of 1. So if there is never an exponent written next to a number, we can always rewrite it with a 1 next to it. So 5 and 5 to the 1st power are the same. So I'm going to write that 5 is equal to 5 to the 1st power. Okay. So now I'm going to use my law of exponents. I have both bases of 5, so I'm going to write down 5. I'm going to take the 2 exponents of 2 and 1, and I'm going to add those together. If I take 2 plus 1, I get an answer of 3. So I have 5 to the 3rd. Again, if I evaluate that, I know that 5 to the 3rd is equal to 125. Okay. Now let's look at another one. Let's look at an algebra 1. We have c to the 3rd times c to the 5th. The base in this case would be c, so I'm going to write down c. I'm going to take the 2 exponents, and the law says that since I'm multiplying here, I'm going to add those 2 exponents. So I'm going to take 3 plus 5. 3 plus 5 gives me an answer of 8. And so there's my solution, c to the 8th power. Again, I cannot simplify because I do not know the value of c. One last example that I want to show you is kind of tricky. This one can be a little bit tricky. I have negative 3 to the x to the 2nd times 4 x to the 5th. The base would be the number or letter attached with the exponent. So in this case, here's the exponents 2 and 5. So the base in this case is x, not negative 3 and 4. So again, the base is x. Because I'm multiplying here, what I can do is I can expand it. I can use my knowledge of expanded form and write this out. So how I would do that is I would write the following. I would take negative 3, and I would multiply it by that other coefficient, because negative 3 and 4 are coefficients, because they're attached with the variable. I'm going to separate those, negative 3 times 4, and then I'm going to separate the x's. So I'm going to have x to the 2nd times x to the 5th. All right. Now that I have it like this, I can simplify it further. I can take negative 3 times 4, which is negative 12. Law of exponents say that I have to take, when I have the same base, I add the exponents. So I'm going to do 2 plus 5. 2 plus 5 is going to give me 7. So I have negative 12 times x to the 7th. Because I'm multiplying here, I can write the x to the 7th right next to this negative 12. And so there's my answer. Again, notice I did not evaluate this one because I do not know the value of x. So this is how you do the product of powers. All right? So product of powers means to multiply. We're not only going to encounter product of powers, we're also going to encounter quotient of powers. All right? So I'm going to write quotient of powers. Quotient means to divide. So now we're going to start dealing with division. All right, here's my first example. I'm going to have 3 to the 7th over 3 to the 3rd. And reminder, this sign right here means to divide. Okay? So in the law of exponents, when I'm dividing or finding the quotient, what I do is I keep the base. So notice that the base is 3. So I'm going to keep that base of 3. I'm going to take my two exponents and I'm going to subtract. I'm going to take the top exponent and I'm going to subtract it from the bottom one. All right. When I take 3 to the 7 minus 3, I end up with 3, and I do 7 minus 3, which gives me 4, which again I could evaluate and find the solution for. Let me show you with an algebra 1. An algebra 1 would look like this. We would have a to the m over a to the n. The base in this problem would be, as you guessed it, a. The first power, or the power that was on top, would be m. The power on the bottom would be n, so I'm going to do m minus n. Again, I do not know the values of m and n, so therefore I cannot simplify this any further. So this would be my solution as of right now. All right. Let me show you a couple more examples. 4 to the 8th over 4 to the 2nd. Base in this case would be 4, so I'm going to write a 4. I'm going to take the exponent of 8, because that's the top exponent. I'm going to subtract it from the bottom exponent, which is 2. Keep the base of 4. I do the subtraction of the exponents, 8 minus 2, which gives me 6. If I wanted to evaluate 4 to the 6th power, I would find out that that solution would be 4,096. Right. Let me show you another one. This one's kind of tricky also. It's not an algebra one, but it can be tricky. 2 to the 5th times 3 to the 5th times 5 to the 2nd divided by 2 to the 2nd times 3 to the 4th times 5. So in this one, what I want to do is, right now these are all joined together with multiplication. What I want to do is kind of separate them but keep it multiplication. So what I'm going to do is I'm going to rewrite this problem as 2 to the 5th over 2 to the 2nd times 3 to the 5th over 3 to the 4th times 5 to the 2nd over 5 to the 1st power. If you want to put them in parentheses, you can. You don't have to. Now what I'm doing, since I'm multiplying and I've got this division underneath them with these identical bases, all right, I'm going to take 2 to the 5th minus 2, because I got the 5 from here, I got this 2 from this exponent, times 3 to the 5th minus this exponent right here of 4. You only need to write the base once when you're dividing or multiplying. Again, the base in this case is 5, so I'm going to write 5. I'm going to write the first exponent of 2. The bottom exponent is 1, so I'm going to do 2 minus 1. I need to move it up. So when I do 2 to the 5th minus 2, I end up with an answer of 2 to the 3rd. 3 to the 5 minus 4 gives you 3. Or I could write 3 to the 1 first. 5 to the 2nd minus 1 gives you 5. If I wanted to continue to evaluate it further, 2 to the 3rd would be equal to 8. Because this is all multiplication, I can go ahead and multiply these together. I'm actually going to do 8 times 5, which is 40. 40 times 3 is 120. So there would be your evaluation answer. All right, let's do some practice.